So let's try this question. It says we have a convex lens. The focal length is 10 centimeter and it is used as a microscope. Solution. The focal length is 10 centimeter and it is used as a microscope. So when it is used as a microscope by a person with normal sight. So normal sight means the person's near point is at 25 centimeter. You can write this as D because it's D that we put in our formula, right? So it is used as a microscope. Now when it is used as a microscope, what does this mean? What it means is that you are supposed to keep in mind all the conditions for a microscope, which are that the object can come within the near point, but the image formed can never go beyond the near point. It's not possible for the image formed to go beyond the near point. Now, the first case is when the eye is relaxed. This is the first case. You should find the magnification when the eye is relaxed. Now, don't forget that when the eye is relaxed, the magnification is what? V over F. The magnification is going to be V over F when the eye is relaxed. Sorry, I'm supposed to write this as D, which is the distance of distinct vision. That means the object is at infinity, right? So when the eye is relaxed, this is the magnification. So that will be 25 divided by 10, and that's going to be 2.5, right? Now, B is when the object is held very close to the eye. Now, when the object is held very close to the eye, you know that that's going to be D over F plus 1. So, and that's going to be 25 over 10 plus 1, and that's going to be 3.5. Or you just come here and add 1 to this, and that gives you the maximum magnification attainable when you are using it as a what? As a microscope. Now let's look at the third question. The third question says when the object is at 10.5 centimeter from the lens. When the object is at 10.5 centimeter from the lens, that means U is 10.5 centimeter, and we have F to be what? 10 centimeter. Now, how are we going to get the magnification in this case? How we are going to get the magnification is that we need V, so that we can do V divided by U as the magnification. So we have to get V. So we are going to say 1 over F is 1 over V plus 1 over U, and this is what? 1 over 10 equal to 1 over V plus 1 over 10.5. Now if you do this, you are going to get 1 over V equals 1 over 10 minus 1 over 10.5. You get 1 over V to be 1 over 10 minus 1 over 10.5. That's 1 over 210. So you get V to be 210 centimeter. We have 210 centimeters. Now look at this. The object is what? At 210 centimeters away from the lens. Now, is this still being used as a microscope? No. Why? Because this is what is going on. You have a lens that look like this. You have the microscope. You have your eye, right? Now have the object somewhere around here, somewhere beyond the focus. It now goes and form image very far away behind. How will you be able to see it? It's not possible for you to see this image. You can only see virtual images through lenses. You can't see a real image. So the image has to be virtual before you be able to see it. That means that the image has to be formed on the same side as the object. So meaning that this 210 centimeter is very far away. It's even behind you. So the image is going to be formed behind you. So how will you see an image that is behind your head? It is not possible for you to see it. So that means that for this particular condition, although the magnification might be big, but it is no longer being used as a microscope. It is no longer being used as a microscope. So because if it's a microscope, it must form a virtual image, right? So the magnification is going to be V over U, because some of us might be thinking that, but we said the maximum magnification is 3.5. Yes, that's the maximum magnification, but that's when they are using it as a microscope. So in this particular condition, it is no longer being used as a microscope. So you just do it as if you are doing for a normal lens. So this will be 210 divided by the object distance is what, 10.5. So if you divide 210 by 10.5, that gives us 20. Look at that, the magnification is 20. The magnification is bigger than the biggest magnification when you are using it as a microscope, but in this case they are not using it as a microscope, right? So let's try the next question. The next question is what? When the image is at 24.9 centimeter, now I'm supposed to add something in front of the user. Now what does this mean? This means that the image and the object are on the same side, so automatically this is a virtual image, right? So what are we going to do since this image is virtual? So we are going to say our U is what? 24.9 centimeter, but it's going to have a negative value because it is a virtual image. Now we know that the focal length is what? The focal length is what do we call it? The focal length is 10 centimeters, right? So the focal length is 10 centimeters. So F is equal to 10 centimeters. So you are looking for V. Sorry, this is supposed to be V, right? This is the image. So we are looking for U. So we are going to say 1 over F is 1 over V plus 1 over U. So 1 over 10 equal to 1 over V is minus 24.9 plus 1 over U. So we are going to have 1 over U to be 1 over 10 plus 1 over 24.9. Now we add this, 1 over 10 plus 1 over 24.9. So we have 1 over U to be 349 divided by 2490. So that U will be the inverse, 2490 divided by 349. So you can find the magnification, which is V over U, right? So V over U is going to be what? What's our V? 24.9. You don't need the minus, then divide by U. 2490 divided by 349. So you're going to have 24.9 divided by this. So the answer is 3.49. 3.49. Now this is because it is being used as a microscope. It is being used as a microscope in this case because it is forming a virtual image. And look at that, the magnification is 3.49, not up to the maximum. The maximum is what? The maximum is 3.5. So it's almost equal to the maximum magnification possible. So this is what? This is a very reasonable answer. Don't forget that we could have said, let's try something. So you could have done this using the normal formula that we derived. So could have done it using the normal formula. Now look at this. When we did this, we got 3.49, right? So that is when the object is at where from the lens? When the object is at minus 24.9 centimeter from the lens. Now this value is actually also not possible because the object, when the object is this distance from the eye, let me say from the eye, it means that the object is now at a distance that is closer than 25 centimeter. The object cannot come beyond 25, come within 25 centimeter to the eye. So that means that this 24.9 is also a distance that makes the object stop functioning as a microscope. So there might have been, let me do this again. So we got 1/10 plus 1/24.9. Then we do the inverse of that. Then we do the object distance, the image distance divided by the object distance. So we have 24.9 divided by that answer. So you have 3.49 for the magnification. Now if you did it normally, because it's supposed to be functioning as a microscope, right? So we are supposed to have it that the magnification is going to be d 1/f minus 1/v. So this is going to be 25. This will be 1/f minus 1/24.9, but this will be minus, so it will become positive, right? So 25 times 1/10, then plus 1/24.9. So let's see what's going to happen. We have 3.50 something, which is greater than 3.5. So this is 10. So the magnification is 3.504. Now something is wrong. You now see that there's a difference in the answers, right? Here we got 3.49. Here we got 3.504. What this means is that it is now at a distance that is closer than what it's supposed to be. So it will have a magnification that is bigger than what it's supposed to be. So we know that the magnification must not exceed what? 3.5, right? Because we got the maximum magnification as 3.5. So automatically it means this object can never be at this distance, and the object will and it will still function as a microscope. It can't be at 24.9 and still function as a what? As a microscope, because when we use the equation of microscope for it, we got a magnification that is greater than the normal magnification. So the reason we got the answer here as 3.49 is because of what? We did it as if it is not a microscope, which is not. So this is the correct way to do it. It will be 3.49, but it won't be a microscope in this case. It won't be a microscope because 24.9 is closer than 25. So look at that, 24. I made a mistake before saying that is less than 25, that it is possible. No, it's not possible. What we are considering is that what? The object cannot get closer to you than 25. Let's assume that this is the image, then the distance between the image and you must be what? 25. Now this is 24.9. that means it is closer than that distance. So that means that it is still going to become bigger than normal. So that's why we have what? That's why we have the value as 3.5, which is greater than the normal when we used the normal formula for microscope. Don't forget that this formula is for what? For a microscope. So since we used it and we got an answer that is greater than the maximum for a microscope, it means it is not possible. It means it is not possible for you to use this lens and as a microscope, and you now have this magnification, because the maximum is supposed to be what? Just 3.5. So that means that in this instance also it is not functioning as a microscope. So that's why you will now resort to doing it normally. So you resort to doing it normally. When you now do it normally, you get your magnification as what? 3.49. So that's going to be the magnification when it is not functioning as a microscope. Please, these are very important things that we should know. This magnification is when it is not functioning as a what? As a microscope, because we did it normally. But when it is functioning as a microscope, we got a magnification that is greater than normal. So automatically it means it cannot function as a microscope at that particular stage and now go and form image at 24.9. 24.9 is greater than what you're supposed to have. Now let's assume let's formulate one more question and say we want to get the magnification when the image is 25.1 centimeter away. And when the image is at a distance of 25.1 centimeter, what's going to be the magnification? Now if you look at this is what is not closer than how it's supposed to be. It's supposed to be at 25, now it's farther than 25. So this makes a lot of sense. That means this is possible, right? So we use the formula for magnification of microscope, because in this case it is functioning as a microscope. So we say d 1 over f minus 1 over v. So this is going to become d is 25, 1 over f is what, 10, minus 1 over minus 25.1. So in this case it will be able to function as a microscope. That's why we are using the formula for microscope. So we have 1 over 10 plus 1 over 25.1. You see that you get an answer that is less than 3.5. Look at that, 3.496. 3.496. So that means that at this stage it can function as a what? As a microscope. So we're supposed to use formula for magnification of microscope for it. So you can also try for if it is not functioning as a microscope. Let's assume, although it's supposed to function as a microscope here, but let's now assume that it's not functioning as a microscope. We have to get the value of u. So we're going to say 1 over f is 1 over v plus 1 over u. So you get 1 over minus 25.1 equal to 1 over 10 is equal to what? 1 minus 1 over 25.1 plus 1 over u. So you get 1 over u equals 1 over 10 plus 1 over 25.1. So you get 1 over u equals 1 over 10 plus 1 over 25.1. That's 351 over 2. 351 over 2510. So u will be 2510 divided by 351. Now let's now get the magnification when it is not functioning as a microscope. That's why we are using the normal equation. So it will be 25.1 divided by 2510 over 351. Uh, 25.1 divided by 2510 over 351. So you have 3.51. 3.51. Now look at it. So that means that when it's not functioning as a microscope, it has a magnification that is even bigger than what it's supposed to be. So that means that whatever value you are given, you have to confirm whether at that value it's supposed to function as a microscope or not. So if at that value it can function as a microscope, please use the formula for calculating magnification of microscope. But if at that value it cannot function as a microscope, then use the formula for calculating the magnification normally, so that you won't be making mistake. That's where people are usually confused. Are they supposed to use magnification, linear magnification or angular magnification? Don't forget that microscopes have angular magnification and not linear magnification. So if it is functioning as microscope, that means that if those values make sense and those values can make it function as a microscope, then use the magnification of microscope for it. But if those values indicate that it is not functioning as a microscope, then calculate the magnification normally, just like this first one that we did, that the object is at 10.5 centimeter from the lens, and when we did it, we got the image distance is even a positive value, so it can be a microscope. Then this second one, when we did it, we started from here, right? So this is 24.9. At this stage, it can't function as a microscope. So if you use magnification of microscope for it, you get an answer that is bigger than what you are supposed to get. So that means that you calculate the magnification normally for this case too. Then for this last one, the distance is what? Minus 25.1. At this distance, it can be a microscope, so you use that of microscope for it. Don't use the normal one. Don't use this. Use this, because it is now a microscope. Do you have any more questions? We have answered all the questions.